Alright, so in this video, we're going to prove that the sum of the measures of the angles in a triangle is equal to 180 degrees. Now, in this setup right here, all we have is a triangle. And what we want to prove is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 does indeed equal 180 degrees. Now, to start out this proof, we're just going to construct our statements reasons table. And for our first step, what we're actually going to do is we're going to construct a new line on our figure. And this line, we are going to say, goes through point B such that it is parallel to segment AC. And so our line is going to look something like this. So as you can see, our line goes through point B, but we're also going to say that it is parallel to segment AC. I'm going to identify 2 points on our line, point P and point Q. So I can give this line a name now, namely line PBQ. So really what we've done here is we have constructed line PBQ such that it is parallel to segment AC. So that's our first step. Now, this line is what we call an auxiliary line because it's a line that wasn't already here when we first started the proof. And so that's the justification I'm going to write for this step. Auxiliary lines. Now, before we move on, what I'm going to do is I'm going to call this angle angle 4, and I'm going to call this angle angle 5. And just to be organized, I'm going to separate my statements reasons table from what we have on the left side of the whiteboard, so it looks a little bit nicer. Now, for step 2, what I want you to notice here is that we have 2 parallel lines being cut by a transversal here and by a transversal here. Now, if you recall, if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Now notice, angle 1 and angle 4 are alternate interior angles. Therefore, they must be congruent. And also, angle 3 and angle 5 are alternate interior angles. Therefore, they must also be congruent. And if you recall, that theorem was called the alternate interior angles theorem. Now, by definition of congruent angles, we know that congruent angles have equal measures. So in this case, the measure of angle 1 must equal the measure of angle 4, and the measure of angle 3 equals the measure of angle 5. And this is the definition of congruent angles. Now, there's another observation that we can make about this figure. Notice that angle PBC and angle 5 form a linear pair, right? That is angle PBC and angle 5. Because those 2 angles together form a line. They form line PBQ. And we know when we have 2 angles that form a line, that's the definition of a linear pair. So that's why angle PBC and angle 5 form a linear pair. And we could say that for step 4. And this comes from the definition of a linear pair. And if you recall the linear pair theorem, that says that if 2 angles form a linear pair, then they must be supplementary. So we also know that angle PBC is supplementary to angle 5. Again, that's the linear pair theorem. And by the definition of supplementary angles, we know that the sum of the measures of these 2 angles must add to 180 degrees. And this comes from the definition of supplementary angles. Now, another thing to notice about this figure is by the angle addition postulate, the measure of angle 4 plus the measure of angle 2 must equal the measure of angle PBC. So we could say that as well. So this is by the angle addition postulate. Now, since the measure of angle PBC is equal to the measure of angle 4 plus the measure of angle 2, that means we could replace this measure of angle PBC with measure of angle 4 plus measure of angle 2. So really, what we can do here is we could plug this in to this. And so this is by substitution. More specifically, the substitution property of equality. But we could actually go further with this. Since the measure of angle 4 is equal to the measure of angle 1, we could also replace this measure of angle 4 with measure of angle 1. And since measure of angle 5 is equal to the measure of angle 3, we can replace this measure of angle 5 with measure of angle 3. And so if we do that, we would get this. And so again, this is by the substitution property of equality. And so as you can see, we have proven that the sum of the measures of all three angles, angle 1, angle 2, and angle 3, is in fact equal to 180 degrees. And so yeah, that's pretty cool that we were able to show that. So yeah, hopefully that helps, and this is pretty much it for this video.